Hello and welcome to the Nordic webinar about M4350. My name is Johan Hoel and I'm the point of contact for you here in the Nordics. Any questions regarding during the webinar, please write in the chat and I will take it after the webinar. I will not steal the show for you guys. My colleague Eric here, sales engineer for the Nordics, he will take care of the talking, and he's also the point of contact for us in the ProAV design team. This team will help you with designing your system, verify maybe a planned installation, but they also do remote support during installation to make sure that the technician on site does everything correct. But even after the installation, they can assist you to solve the issues. So this is a really great resource both for you and your customers, and will make sure that all your installations will go smooth in the future. But now, Eric, my colleague that joins me in all the trainings in the Nordic, we travel around every country to train and train and train to get everybody up to speed. Welcome.
Thank you, Johan. Hello, everybody. I'm Eric Lindeman. I'm working for NETGEAR about 10 years now. I started as a specialist in Wi-Fi and switching, but halfway through, I became more and more involved with AV over IP. So after the arrival of my colleague, IT colleague, Gillian Roosevelt, I started doing dedicated pre-sale support and training for resellers for our ProAV solutions. So another thing to add, I prefer to have the questions in the Q&A box. This because I can capture the questions, and if we need to go back on the question, we have your details, and so we can react on your questions. And at the end of the webinar, we will start answering the questions. Okay, so far so good. So I give you a sneak preview of the agenda. So what we're going to discover is the trends in AV over AP. I see a lot of trends, and I take two of them and will show you and give you an idea where we, how we started to develop the M4350 series and where to position it. And I also going to compare the switches against our recent switches, the M4300 and the M4250. And I'm also going to discuss a little bit of the AV topology, so you get an idea how to position the switch in the network topology and AV topology. And of course, at the end, we will do the Q&A. So far, so good. So what we see as trends, we talk a lot with AV manufacturers, we talk a lot with VARs, and we have two significant trends to show you, because there are plans for 8K developments. We see the trend in video walls, and we also see the trend on the large QLED screens. By example, this taken by a midwit company Van Domburg in the Netherlands. And if you look very good at the right side, you see the bright sign player. And if you know the size of the bright sign player, you get an idea how big the screen is. And if you fill it with an image of 4K, yeah, it will be good, but better is to use 8K in this kind of solutions. We should also see a trend coming with compressed 8K video. But the big bottleneck of that is that 1 gigabit switching will not be enough to deliver enough bandwidth for 2.5 gigabit. So that's why there is a little trend coming up for the future, and we are going to adapt it right now. So everybody and also the manufacturers are prepared to introduce their new products. But what you see in the bandwidth needed, I draw a little triangle. So if you look right under it, you see a little marker for full HD. If you see it or compare it with 4K, you need a lot more bandwidth for 4K. And if you want to transport 8K over your network, then the bandwidth will be tremendous. So that's a little bit of a figure to see that you need 2.5 gigs to have enough bandwidth for 2.5 gigabit. But not only bandwidth is a part of the deal, there's also rising demand for PoE devices. When I started 5-6 years ago, every encoder decoder sold by the manufacturers have their remote power supplies. What we see nowadays is that every encoder decoder has its own PoE cable and will be fed by PoE. Even controllers are fed by PoE, and that's most of the time PoE of PoE plus is enough wattage to drive those devices. But what you also see is, in this example, a little amplifier, network amplifier from AVoIP. You see that there are two settings in this amplifier. One, if you want to use the half of the power of the wattage. There's a little switch that you can connect it to PoE plus. And if you move over the switch, you need PoE to have the full wattage of this device. But you don't see it also with loudspeakers, of course. There are some manufacturers from loudspeakers also feeding their powering their devices over PoE. And we also see the cameras. If you look at cameras for Bright, Burdock, and a lot of other brands, you need more than 60 watt to power those cameras. This is because of the motor for the lenses, the power, the pen and tilt motor, and that kind of things. So you need above 60 watts to feed those kind of cameras. So that's also a point we have taken in consider with the development of our M4350 series. So a little review. You need multi-gigabit Ethernet. So we introduce switches with multi-gigabit Ethernet. Of course, we also respect the 1 gigabit switches and the 10 gigabit switches of the M4300 line. Uplink speeds are raised from 10 gigabit for the 1 gigabit switches, but if you buy a 2.5 gigabit switch, the uplink speed will be 25 gigabit per port. And we also consider a reduced fan noise, because when you know the M4300s, they are rather silent, but most of the time not silent enough for AV deployment. So that's the big points we took into consider with developing this switch series. We also still support Engage, our management platform. So nowadays all our 4250 series, M4300 series, and M4350 series are manageable by the Engage controller. We have speed from 1 gigabit, 2.5 gigabit, 10 gigabit, 25 gigabit to 100 gigabits, and all within a depth, a rack mount depth of 40 centimeters. And that's, I think, rather unique, especially when you go in phase 2 the 100 gigabit switches. It still only takes 40 centimeters in depth to mount the switch. So every decent pod rack is capable of mounting this kind of switches. And when you look at our M4500 series, you need at least a server rack to install those switches. Of course, auto lag, auto trunk is still available into the switches. IGP Plus, of course, is also, so the thermal conditions of the switches and the acoustic switches are taken care of. So when you look at the back of our switches, you see a big difference with the M4300 series is that we have a built-in power supply. The built-in power supply gives us the possibility to manage the fans more precise, and also to reduce the fan noise tremendously against the M4500 series. In most of the cases, it's 2 times as silent as an M4300 series. What you also see is we have 2 slots for extra power supplies. And when you need redundancy, or when you need to raise the PoE budget for some switches, you can add extra power supplies to have sufficient PoE budget, or to get redundancy, or sometimes both, of course. Depends on the power supplies you insert into those switches. So this was the little introduction, and now I would like to discuss some things we have discovered, or some things we are using as an AV topology, and it differs a little from the IT topologies. So let's start with the most simple topology. It's a standalone switch. For the switch, you can connect devices. So far, so good. And when you're running out of ports, you have to introduce another switch. So you can connect the switch to another switch, and then you see another kind of terminology. Most of the times, the switch, the central switch in the network, will called in AV the spine. In IT, we call it the core switch. And for the switch at the edge or the leaf at the bottom of this slide, you see a leaf switch, as we pronounce it in AV, and in IT we call it an edge switch. And I'm introducing this terminology because it's I think it's essential for an AVer to know a little bit about the jargon, or how do you call it, the way of speaking for IT guys. What we also do for this kind of solutions, if we getting out of bandwidth, you're able to add another cable between those switches, and at immediate auto trunk and auto lag will become active between the switches, so you can gain extra bandwidth without any kind of configuration into the switches. So it will be full automatically. The lag will be configured as soon as you connected the second cable, and also the VLANs will be trunked automatically when you have different VLANs over those switches. And if we extend the network, it's quite simple by adding extra switches, and the spine core will be the heart of your network, and the other switches will be connected to the spine, leaving a good result of latency, of course. And there's only one point of attention into this design, and that's the capacity between the switch and the core switch. So you need enough bandwidth for all your traffic, especially multicast traffic, from the leaf to the spine and back from the spine to the edge switch. So you always have to do the math in calculating the bandwidth. And if you have sufficient bandwidth, everything will run very secure and very good. In terminology, we call this kind of topology a star topology. So it's look a little bit like a hub and a spine, and yeah, it's a star topology for connecting all those switches together, leaving you in a very predictable network, easy to calculate network. So we have another topic, and that's stacking. But there's a lot of confusion about stacking. So I'm first going to discuss what NETGEAR doesn't understand, or what mean by stacking. And later on, I'm going to discuss what NETGEAR is meaning by stacking. So let me first introduce the stack. The stack is a couple of switches connected to each other, and most manufacturers are calling this already a stack. The switches are connected to each other, and now we see immediately a problem, because when we connect those switches with Ethernet, the spanning tree protocol has to be active and block one of the ports, so the ring is broken, because Ethernet is not designed to having a ring topology. So far so good. So spanning tree will do the job automatically, and this network is good to go. But what if the third switch will drop? You see the problem immediately. The second switch also will drop a connection, and it takes a couple of seconds to recover the connection with spanning tree, and then the rest of the network is good to go. But if you have a stream running over your network, a video stream, especially also a clocking stream, you have to start over all the streams again, because yeah, the timeout is too long to maintain all the streams on your network. So far so good. If you introduce the extra switch, also spanning tree will recover the connection, and you're still good to go, and you have a great solution in IT point of view, but not in AV point of view. If you see those switches are getting an IP number by themselves, so every switch has a unique IP number, and you still have to manage all those switches by the IP numbers. What some manufacturers are doing, they have created a Windows console, a Windows-like console, and so by this way you're able to connect all the switches by one IP number, but that's still not the approach how NETGEAR has designed stacking. But what does NETGEAR mean by stacking? Okay, for stacking, we have a stacking ring protocol. And that differs from Ethernet because a ring protocol, this ring protocol is designed to have a ring between your ports. So the ring protocol will be available with the 10 gigabit or higher ports. If you have 10 gigabit ports, you have shared 40 gigabits in the stack of 8 switches. If you have 25 gigabits, you will have a shared ring of 100 gigabits. So that sounds very promising, but it's a point of attention, especially for AV, and I will explain you later on in this webinar. So if you connect even an extra ring, you have twice the capacity. So remember, every port you configure for stacking is 10 gigabits or higher into this new switching range. The 1 gigabits and the 2.5 gigabits are not capable of stacking. One switch in the stack will be the stack master. The rest of the switches will be the stack member. One switch will also be the operational standby of the stack members. And what the operational standby switch is doing is he's copying or requesting all the tables from the master switch and insert the data into his own table. So when the master switch is failing, standby switch will be immediately the active switch. The good thing of this story is that if you, because the switch already has all the tables, all the MAC addresses inside these tables, there doesn't have to be an ARP over your network to build up the tables again. So at the max, you will lose one Ethernet packet, and even UDP traffic will survive from losing one UDP packet. So that's the very good news. The other good news is that you also need one management IP address to configure this stacking switch. And the other thing is that it's only for ICT purposes. Why don't we support stacking, especially on the edge in an IV situation? And that's quite simple to explain with this animation. So when I connect an encoder on this edge switch and a decoder on the same switch, and I start the transmission of the unicast signal, you see that the encoder will also send all multicast traffic over the stacking ring, because the benefit of stacking is that complete the stack will act as one logical switch. So in a normal switch, every multicast signal will be sent over the backbone of the switch, but in this case, the stack is the backbone. So if you add an extra decoder, you still have the same problem. Every multicast signal introduced will be sent over the stack itself. To get a little bit more of insights, if you look at the stacking protocol itself, it has bandwidth between the switches of 20 gigabits. So the switch has 10 gigabits up down in and 10 gigabits up down out of the switch itself. And we call that a 40 gigabit shared bandwidth. And when you start adding extra encoders, decoders, in this case it still will work, but it will be very difficult to calculate where all those streams will exist on your network. And if you connect a couple of extra encoders, the stack will fill because there's not enough bandwidth in the stack to cover all the multicast streams. So that's the reason why we don't support multicast. In multicast environments, the stacking, especially on the edge of your network. So please remember this, and I hope this explains a little more about edge stacking. But we can still use it for ICT. It's very good there, and you can also create an extra stack that we call a core stack. And for a core stack in ICT, we also support 2 switches, and you can connect your ICT edge stack with your ICT core stacks with LSCP with ease over those switches. And for this situation, you see you have 40 gigabit up and 40 gigabit down bandwidth from the core to the stack. So that's, I think, a very good solution, especially for ICT. And when you connect a database server or an SQL server or a mail server on the stack with two network adapters spread over the two switches, and one switch is failing, you still have 20 gigabits up, 20 gigabits down from your core to your edge. So that's a very decent solution, especially for IT. But what can we do with stacking and AV? We can use stacking as an AV spine switch under certain conditions. So when you look the proper way for the AV situation, you can use multicast video only when you introduce stacking into your network. You can also use maximum 2 switches in your AV spine stack. In this example, you don't have shared bandwidth. You have the full bandwidth between the stack. So it makes life very easy to calculate if you have enough bandwidth between those switches to handle all your multicast traffic. So that's a point of attention. And as long as you're using multicast video, good to go. But when you want to use AVB support or you want PPTV2 clocking support, then the stack is not able to contribute the loss of time into the switch and report it back to a master clock. So you're running into troubles when you want to use AVB or PPTV2 clocking with this stacking model. When you have AVB into your network, PPTV2 clocking, or even 702110, please don't use any kind of stacking and use other methods to connect or to create redundancy into your network. What you see here is a little picture about AV leaf switches and a spine stack. So it's easy to hook up this kind of switches to your stack. And with this example, you have 40 gigabit up, 40 gigabit down between your switches. And if one of the two switches in the stack is failing, you still have 20 gigabit up and 20 gigabit down. So do the math and calculate the right way and use stacking when it's good to go. Avoid stacking when you're using clocking protocols. A little example of clocking is with AX67 and with Dante. And most of the time for redundancy with the Dante interface or the AX67 mixing console or whatever, you see a primary and a secondary network connection. So what you can do with the primary and the network connection and secondary network connection is create a network consisting about two networks, a primary network and a secondary network. So what you can do, you can add some extra switches for the secondary network. Don't make any other connections between those networks. Connect you interfaces on the switches. And with this example, I took two Genelex speakers, but it could be also an extra mixer or an extra device with a primary and a secondary interface. And as long if there's traffic, the audio signal will be sent over both of the switch topologies. And if one of the cables or one of the switches broke, you still have an audio signal on one of the primary or secondary network. And you're still good to go. So your audio will not be lost with this kind of solutions. But there are also some other things to keep in mind, especially with this kind of solutions. And in this picture, I draw our half-width switch. So if you have not much space in your audio rack, you can connect or you can mount two switches in the place of one U, and that's very efficient and make the audio core of this kind of switches. I have a little example with our former switches or the M4350 series in practice. This is a live situation where we also use the half-width switches, and you see two PDUs. Both PDUs are feeding another switch, are connected to another switch. So if one of the power feeds are dropping, you still have power on one of the two switches, and you also see that the wiring is yellow and red for this situation. So there's a lot of difference between the cabling and they paid a lot of attention in installing this solution. So maybe this is a nice example to connect those switches. Okay, so far so good. So let's go a little bit of try to zoom in a little bit of the positioning and the compare of the M43 switches against the other switches. So for this I have a little lineup. On top we have the M4250 series, mainly 1 gigabit switches. One switch with 2.5 gigabits, and about 80% of those switches have a 10 gigabit uplinks. The smaller switches have 1 gig uplinks. We have our good old M4300 series based on 1 gig 10 gigabit ports, and if you have the modular switch you can have 40 gigabit uplinks. The rest of the switches will have 10 gigabit uplinks. All the switches have redundant power supplies by external power supplies itself. There's no power supply built into the switch, so they are a little bit noisier than the M4350 series. And the M4300 series has no AVoIP. The M4350 series will have AVoIP. By default, you have 1 gig, 2.5 gig, 5 gig, 10 gig ports, 25 gig ports, and 100 gig uplinks. There's a built-in power supply, of course. I mentioned it earlier. You can add redundant power supplies or gain up the PUE budget by adding extra power supplies. And later this year, when we have the phase 2 switches, also SMPTE 2110 will be supported on selected models, and the selected models are the switches of those series with the 100 gigabit uplinks. We also have the M45, still have the M4500 series. The M4500 series will have more 100 gig ports. When I give a brief overview, you see all the green switches are the phase 1 switches. Mainly there are 1 gigabit multi-gig switches with 10 gigabit or 25 gigabit uplinks. And the blue switches in this list will be introduced in January, end of this year, beginning next year. And you see that there is the majority of those switches have multi-gig ports, a rather high PUE budget, and there are also 2 switches with 100 gigabit uplinks. So that's a brief overview of those switches. So when I go back to the topology, you see a little drawing, and what I'm going to discuss now are the leaf switches. So let's take a look at the 1 gig switches. So here you see both of the 1 gigabit modules. On the left you see the 24-bit 24 ports version. The PUE version is 30 watts per port, PUE plus, and you have 10 gigabit SFP plus ports for the uplinks. What you see below is that there is a built-in power supply, and there's an extra slot to gain up the PUE budget, and it will be PUE redundant up to 648 watt, because that's the default PUE budget. When we look at the 24 ports, we see that the uplinks are the same. There's 4 1 gig ports. For uplinks, you have 48 1 gigabit ports, also PUE plus, and because the port count, we added 2 slots for for extra power supplies. So if you add 1 gigabit 1 times 2000 watt power supply, all ports are capable of delivering 30 watts. And if you add an extra power supply, you have redundant power supply on all ports. So that's a brief overview of the M4350 series 1 gig series. When we go into details on the ports, you can see a major difference between the M4300 and the M4350 series. And this is because of the uplink ports. The M4350 4300 series has copper uplinks, or your 45 10 gigabit Ethernet uplinks, and also 4 of 2 fiber SFP plus slots uplinks. So that's, for the time we designed the switches, that was good to go. So the people had choice to use copper or fiber. But when we look deeper into the AV market, you can expect that the distances between the switches are, and you want to get out with 40 gigabit, get out of the switch with 40 gigabit, the difference of the copper cable will be a bottleneck. So that's why we decided to have all edge ports of those switches, the SFP plus slots, resides from fiber optics. So if the distance between the switch is 450 meters or maybe 10 kilometers or 120 meters, you're still capable of connecting the switch with the full speed to your core. So that's a big advantage, and that trend we also started with our M4250 series. So all uplinks are fiber optics, and when you still need RJ45 copper uplinks, we have some modules which you can plug in, so you can still capable of having an Ethernet, a normal copper Ethernet connection to this 10 gigabit uplink port. That's one of the difference. The other difference is that if you look at M4250 series, you see that the uplinks also for this switch is 2 times line rate. If you go to the M4300 series, you have a max of 40 gigabit uplink speed. There is some difference in acoustics because the M4250 you can shut off the vents, so it will not make any noise at all. And if you look at the M4300 series, you can see that there is AVB support out of the box, but you lose AVB support when you use stacking. And the AVB switch, the M4250, you can also have AVB support, but you need to buy a license to get AVB active. For stacking support, there is no stacking support at the M4250 series. When you look at the M4300 and the M4350, you can stack up to 8 switches. But keep in mind that in an IT core, you can use only 2 switches for stacking. And for AV, the best practice or the supported way to use stacking is in the core, when you don't use clocking signals with a max of 2 switches. PPT support, V2 support is also transparent, available on all those switches, but you lose it stacking into your network. So that's a little point of attention. And when we go to the taller port count switches, then you look at the M4250 series, you're still capable of having twice line rate outputs. So the 40 port switch has 80 gigabit of output. So when you use it to a redundant core, you can still have a non-blocking output when you connect all 8 ports, all 8 10 gig ports to your network core. And the M4300 and 4350 series will still have a limit of 40 gigabit uplink to the port. In most cases, it's significant, but be aware to do the math or calculate the bandwidth if you want complete redundancy into your network. When you look at the acoustic noise, you see that M4350 is very silent at 29 dBA. And when you compare the M4300 to the M4350 series, it's twice as silent as the M4300 series. So it takes it's 6 dB lower for the M4350 series. Okay. What we see here is another beautiful edge switch. In my opinion, it's very usable. It has 44 2.5 gig ports of PV++, 90 watt per port. You have 4 ports of multi-gig 10 gigabit, also 90 watt per port. And then at the edge we have 4 fiber ports, SP28, and that there is a way to get out with a 100 gigabit of bandwidth to have enough bandwidth to a core. You can use also in this switch in IT if you're using Wi-Fi 6 or later on Wi-Fi 7 access points. So it makes a lot of sense, and there's plenty of PV budget to add by adding the extra power supplies. So that's very good. And yes, it's a very nice switch also for future deployments. There is also a nice solution for the switches to connect all the switches to a spine core. So if you going to use in the next slide to be introduced spine core switch, you can use our 40 gigabit switch with our edge switch with 24 ports. You can connect it with 40 gigabit to the spine core. You connect the 48 port switch with 40 gigabit to the core. And when you use the 4 other wires with 100 gigabit, you can connect the 2.5 gigabit leaf switch also to your core. So you get nice speeds between your core and between your edges. And of course, outer leg and outer trunk will be introduced automatically when you connect all the switches to each other. When you go look at the other switch, those switches are going to introduce now are usable as the leaf and also usable at the spine. At the leaf for SDVUE kind of networks or networks when you need 2.5 to 10 gigabit at the edge. And at the core, you can use it for the 1 gig and 2.5 gig, 2.5 gigabit switches. So let me look at the models. If you look left, you see the Ethernet, the copper version of the switch. It has 24 ports, 1, 2.5, 5, 10 gigabit copper ports with PoE plus of 30 watts. And you have 4 25 gigabits at the edge. There is the possibility to have an extra power supply to raise the PoE bit or to get 567 watts of PoE redundancy. And at the right, you see the fiber switch. It has 24 ports of 10 gigabit SFP plus, and you have of 25 ports uplinks for the switch. And you can add an extra power supply of 350 watts to have redundant power into the switches. So far so good. Also very great switches, especially when you're using the M4250 series and you need to create a lot of fiber for the uplinks. So it's a very good core or spine switch. When we go to position a little bit about the redundant spine, you see our switch here, formerly introduced switch, the fiber switch, the last introduced switch on my spreadsheets. You can connect, you can create a fiber by fiber modules. You can create a stack with a 200 gigabit throughput between the switches, and you can connect the edge switches line rate, in this case an M4350 40 port switch to one switch, and add an extra line rate connection to the other switch. So if one of the two switches in the spine get unpowered or broke, you still have the full capacity of the 41 gig ports to your core, and the other switches are based on 10 gigabit uplinks. So you have 40 gigabit on 24 ports and 40 gigabits on the edge switch of the other switch. So yeah, you can create a great network. You can create some redundancy as long as there's no clocking involved. Of course, still here outer trunk and outer leg. When we look at the half-width switches, we have an 8x8 switch, 8 fiber, 8 copper. And we have a 12 port, 12 fiber, 12 port copper switch. And you can mount them together in one view in a rack. You can also mix them. And when we compare those switches to our M4300 switches, the big difference is that the ports are swapped. So when you look at the M4350, the left ports are copper Ethernet and the right ports are fiber Ethernets. And with the M4300, you see that the ports are mounted at the opposite. Also, the management is gone to the back of the switch, saving a lot of room in the front, especially for the 12 port switch. What you see at the edge at the back of the switch, you see the built-in power supply. You see 3 fans, also making reducing the environmental noise very tremendously. At the right, you see the back of the switch. You see a built-in power with a swappable power supply, and we are only able to control the fan installed into the switch, and onto the CPU, but not in the power supply. Because it still makes less noise than normal, but still makes noise. So we solved it with the built-in power supply. That's the other good thing. And a little bit thing about positioning. the switch. You have the spine core in this situation, and you have the 10 gigabit switches. This is a newer switch we're going to introduce in December, and is deliverable in January. The switch has 25 gig ports and 100 gigabit uplink ports, so it's easy to connect later on our 10 gig switches to a 100 gig core, giving also a great bandwidth application between those switches. And we also going to port 702110 on those switches, making also the broadcast solutions or big video wall solutions also cost effective with our switches. So what you see is Panasonic and Sony have nice cameras, and when you connect them up later on to this switch, you have a very good solution, and with all respect of 702110, so you can use it in a production environment. So far so good. What do we offer else? Of course, our 90 days technical support for end users. We have lifetime support, technical support, and online chat for end users. For our resellers, we have our SDVUE team answering all your questions, so there's no 90-day limit on the support, and we have a lifetime warranty for the first owner. We also have the Pro AV design team. Johan already mentioned we do pre-sale support, after-sale support. We assist with network designs. Those people running in those team are dedicated for AV questions and assistance. It's spread over the world, and it's a 24/7 accessible just by dropping a mail to proavdesign@netgear.com, and they are contacting you in a short amount, between about 10 minutes to 2 hours, when you place a question or you email them with a question. Of course, we have the NETGEAR Academy, so when you subscribe to the NETGEAR Academy, you can do some trainings, and at the end of the training you can achieve a certification by answering a little questionnaire. So NETGEAR Academy, sign in, register, and you're good to go. And that's why NETGEAR Pro AV. So we take a lot of care of our designing our hardware, as you see in this webinar. The switches are, of course, IT switches, but when you look at the uplink speeds and the silenceness, the PV budget, we take care of placing those switches in an IV environment. Of course, we have some extra software inside of switches, and also a remote software to configure those switches called NETGEAR Engage. We have IGP Plus. We have also support with the Pro AV design team. So I think, after all, this is a good solution, and I think we can do our questionnaire right now for the Q&A. So there are some questions.
Yes.
Okay.
You want me to write it out, and you can just answer it?
Thank you, Johan.
There's a question if they can get the presentation PDF afterwards.
Yes, why not?
Yeah, so that's of course possible, and then
drop me an email, and I will send you the presentation, or drop you an email, because he also has the presentation.
Yeah, so that's also a question regarding a copy of the video, etc. But we will send out an email. And then we have a question regarding if the case is that the only switches that have redundant power is the M4350 and the 96X. Is that correct?
Not completely. If you look at the M4250 series, we have the Ultra PoE switch, and what you see on that switch is 2 U high, and we also have 3 power supplies. So if you stay within the budget of 2 power supplies, you still have redundancy on those switches, and that's also for all the other Ultra PoE switches with the 40 port count. They still have 2 power supplies. If you go to the lower power budget, the M4300 series is always is always 2 slots except for the half-width switches. So the half-width switches have only 1 power supply. And for the other switches, for the M4300 series, you can add 2 power supplies. And for the M53 series, for the new series, of course, there's a built-in power supply, which you can add an extra, or with some modules, you can add 2 power supplies to make it redundant.
Yeah, and that also, we have a question, what happens when a PSU fails? Will there be any delay or loss of packages, and how does that affect the PoE?
If you do the design properly and calculate the PoE budget, you don't use any packets on the switch itself. So if you have a redundant, let's, by example, take our fiber switch, the 24-port 1 gig uplink. When you add up extra power supply, and one of the power feeds is dropping, you still have the switch up and running. You don't lose any packets on the switch. So when you create a stack from those 2 switches and connect it to each other, and then you connect your other switches to the stack, spread it over the stack, over the 2 switches, then the point of attention is the uplink from the switch you connect to the stack to switch A and switch B. And that's why I like the 10 ports and the 40 port gigs of the M4250 so much, because they have twice the capacity of the ports. And just as I explained in the slide, if you have a 40 port switch from the M41 series, you take 4 ports and connect it to the top switch of the stack. You take the other 4 ports, 10 gig ports, and you take it on the switch B on your stack. And of course, when one of the switches in your core is failing or running out of power, you still have the complete uplink capacity from your edge switch to your core switch. Okay?
Yeah. We also got a question to explain the basics of the IGMP Plus.
Yeah, the IGP Plus is filter, taking care of a lot of PIM commands and access control lists, preventing an IGMP signal going to your spine switch. So, by example, if you have multiple switches in your network, and your central switch, your spine switch, is the IGP carrier, and you introduce on one of the switches, you introduce a multicast switch signal only for that particular switch, then always the multicasting signal also travels out from the switch to your spine switch. And to avoid this, you have to make a lot of complex PIM settings and even configure access controllers into switch to prevent the multicast traffic leaving the switch. For this, we create a NETGEAR protocol called IGP Plus, so a little bit extra. And this is an automatic filter preventing a multicast stream leaving a switch to your spine switch if there is no other traffic or no other request for the multicast signal from that switch. So maybe I have explained it a little bit.
Yeah, so in short, it's if the multicast stream is not needed anywhere else or requested anywhere else in and then in the switch itself, it won't leave the switch, so you save a lot of bandwidth.
Yeah.
So super simple. Then another question is, do the M4350 switches also have the same possibility to run in low noise mode?
Yeah, low noise mode is always available, of course. And it's stepping up, the cooling of the fans are stepping up as the environment getting warmer. There is no still mode. So with some switches on the M4250 series, you can shut off the fans. And when the temperature rises above 27 degrees, the fans will start cooling, and it's adjusted to the environment, the temperature of the environment. So if the temperature is around 27 degrees, there's very low noise, and it will step up. But there is no there is a silent mode in the switches, but there is no still mode in those switches. And in silent modes, the switches are around 30 dB, at the max 40 dB. and when you add extra power supplies, the count will, the noise figures will raise a little bit.
Yeah.
Does that answer?
The next question is actually something I can answer. Is the switches already in stock, or when can we get it? And then I can say that we have all the switches marked in green in the presentation are available as today. So if the distributor you normally buy from don't have it in stock, it's roughly a week delivery time.
Yeah.
From the order.
Mm-hmm.
And the final, I see that we are running a little bit over time now, but the final one that I want to cover today, or I will bring up, the rest we will answer directly to you. So we will not need to buy a license for AVB in the M4350. Is that correct?
Yeah, the license is involved.
So yeah, it's included.
Yeah. So no keys, no extra order, nor no SKUs. It's still there, and
Yeah.
you can activate it if when you needed it.
But then I think that's it for today.
Yeah, there's only one question about the recording. The recording will become available later on.
Yep.
Okay.
But then thanks you all for joining.
Yeah.
If there's anything else afterwards, just reach out to us. We are here to help.
Okay.
Don't forget about the Pro AV design team.
Yeah.
That's a really good resource for you. Thank you.
Okay, thank you. Bye-bye.
Bye-bye.
See you.